Alrighty, welcome back, boys and girls. It's your main mathematics coming to you live from Summit Academy. In this video, we're still working on that unit number 7, lesson number 2 now, and we're going to be able to explain and use a rule for multiplying powers of 10 and how those apply to those exponents. So for the first part, it says Claire said that she sees 100, Tyler says that he sees 1, and Mai says that she sees 1 out of 100. Who do you agree with? So what you can do is think pair share, and you can pause and work with your partner to try and figure this out. What you can also say too is any of these can be correct because there are 100 small squares and 1 big square. And then you could say each small square is 1/100th of the large square. So any of those options would be totally fine. Moving on to the second part, it says in the diagram the medium rectangle is made up of 10 small squares. The large square is made up of 10 medium rectangles. How do you represent the large square as a power of 10? So we can say this, we can say the large square can be seen as 10 squared because there are 100 small squares. Then we could say if each small square represents 10 squared, then what does the medium rectangle represent? So we can say the medium rectangle represents 10 to the third power because if we multiply those two together, we have 10 squared times 10 is equal to 10 to the third power. Then we can say the large square represents 10 to the fourth power since 10 squared times 10 squared is 10 to the fourth. So make sure you're very careful when you're writing these down. Again, make sure you're seeing that the exponent, again, make sure as a reminder, let me have this on here. When you have your exponent, you're going to say you have your base, and then you have your exponent attached to it in the superscript. So we're going to say this is exponent. All right. So then for the next part, it says for number 3, it says if the medium rectangle represents 10 to the fifth power, then what does the large square represent? And what does the small square represent? So we can say this now. We could say if the small square represents 10 to the fourth, because if you take 10 to the fifth power divided by 10, it's like you're subtracting those exponents. So notice how in those first two we added the exponents, but now we're subtracting because we're dividing. So that means that the large square would represent 10 to the sixth because we have 5 plus 1 is equal to 6. Then for number 4, it says if the large square represents 10 to the 100th power, then what does the medium rectangle represent? So we can say the medium rectangle represents 10 to the 99th power because we subtract 1 from 100 to get the exponent of 99, and then the small square represents 10 to the 98th power because 10 to the 100th power divided by 10 squared. It's like we're subtracting, so it's almost like we are, let me underline those two. So when dividing, subtract exponents. All right. However, when you're at multiplying with the same base, you end up adding those exponents together. All right. For the next part, towards the bottom, it says complete the table to explore the patterns in the exponents when they're multiplying powers of 10. So notice how you start with your original expression and then you have it expanded out. So notice how they have for 10 squared, they have a 10 for each of those values in the exponent. For 10 to the third power, however, they have 3 10s because they have 3 in the exponent. And so again, add those. So add the exponents when multiplying the same base. So it only works when I have the same base. But that's how they do 2 plus 3 is equal to 5. So make sure you're not multiplying the exponents, you're adding those exponents together. So that means for this next one, we're going to say if we have 10 to the 4th power, if we expanded that out, we're going to have 4 of these 10s, 1, 2, 3, 4, and then 10 to the 3rd power is 3 of those 10s, 1, 2, 3. Add those exponents together, we're going to say this is going to be equal to 10 to the 7th power. Similar idea for the next one, we're going to have 4 of these 10s times 4 of these 10s, add the exponents together, 10 to the 8th power. And then now it gives us the expanded form, so if we count, we can say we have 1, 2, 3, and we have another 1, 2, 3, 4, 5. So all combining those together and writing the expression, we can say it's 10 to the 3rd power, which is the same as 10 to the 8th power. So add those exponents together, and then if you notice the next one, it has 10 to the 18th power times 10 to the 23rd power. Instead of having to crunch all those in, what we can say is this. We're going to say the expanded form is too long, just add those exponents together, and so instead we're going to have 10 to the 41st power. So then it says for number 2, it says use the patterns you found in the table to rewrite 10 to the n power times 10 to the m power as an equivalent expression with a single exponent like this, where it has 10 to the power and has a little blank in there. So what we can say is like this. The key idea for today's lesson is this. When we have those exponents with the same base, we can add them together. So make sure you're adding those exponents together. So we do n plus m and the exponent of 10, because multiplying n factors that are 10 with m factors that are 10 results in n plus m factors that are 10. And it says use our rule to write 10 to the 4th power times 10 to the 0 power with a single exponent. What does it tell you about the value of 10 to the 0 power? Well, what we're going to say is it's going to be just 10 to the 4th power, because we have 10 to the 4th power times 10 to the 0 power is the same as 10 to the 4th plus 10 to the 4th plus 0 and the exponent, which means 10 to the 0 power must be equal to 1. So again, any non-zero number to the 0 power is just going to be equal to 1. Then at the very bottom, last little question before you turn to the back, it says the state of Georgia has roughly 10 to the 7th power human residents. Each human has roughly 10 to the 13th power bacteria cells in their tract. And then it says how many bacteria cells are there in their digestive tracts of all humans in Georgia. So again, this is just, estimating, but what we can say is this. If we actually multiply those two numbers together, we can say there are 10 to the 20th bacteria, because 10 to the 7th people times 10 to the 13th bacteria per person is equal to 10 to the 20th power total bacteria. All right, moving to the back for that practice, it says write each expression with a single exponent. And so what I'm going to do is I'm going to do these first two, and then I want you to try the other ones on their own. So add exponents. So I have 3 plus 9 is going to be 12, so 10 to the 12th power. Again, if I don't see an exponent there, just make sure you assume it's 1. So when you do not see exponent, know it is 1. It can't be 0, because if it was 0, we would just write this whole term as 1. So we're going to write that we have 10 to the 1st power times 10 to the 4th is going to be 10 to the 5th power, because we add those exponents together. And for these last few here, what I'm going to say to do is pause for your turn and check with me. All right, moving to the next part. It says a large rectangular swimming pool is 1,000 feet long, 100 feet wide and 10 feet deep. The pool is filled to the top with water. It says for part A, it has what is the area of the surface of the water in the pool. So what we can do, just talking about that rectangle like this, we're saying it is 100 feet wide and 1,000 feet long. And then we need to find the area. So we're going to say the area of this is going to be equal to the length times the width, which is just going to be 1,000 times 100, which is going to be equal to 100,000 feet squared, since we're talking about the area. Then for the next part, it says how much does the water pool hold? Or how much water does the pool hold, which means we're going to be looking for volume. So make sure you can use those words to be able to kind of define what action you're going to take. So we can say the volume is going to be equal to the length times the width times the height. So add those. But let's make sure we multiply. So we're going to multiply these three terms together. So we have 1,000 times 100 times 10. We're going to say that is going to be equal to, it should be 1 million. So we're going to have 3, 4, 5, 6, something like that. Alrighty, so we're going to say 1 million feet and then cubed, since we're talking about volume. Alrighty, and it says expression. For part C, it says express your answers in the two previous questions as powers of 10. So in part A, all you have to do is this. Let me write this down. So let's count zeros and write as exponent. So what that means is this. If we look at A, part A, our answer was 100,000 feet cubed. And so we're going to count the zeros. We have 1, 2, 3, 4, 5 zeros. So that just means that we could write our answer like this. We can say 10 to the 5th power feet squared is going to be that volume, or sorry, that area for part A. Then for the volume of part B, same idea, count the zeros, 1, 2, 3, 4, 5, 6. So we're going to have 10 to the 6th power feet cubed for that one. Moving on to number 3. A little bit of a review here, but it says here is a triangle ABC, and triangle DEF is similar to triangle ABC, and the length of EF is 5 centimeters. What are the lengths of DE and DF in centimeters? So it gives you the original. So let's label this the original. And what we have to do is we need to draw our new one. And we actually know, if you ever get stuck on trying to line these up, we can say something like this. We can say, all right, we have A, B, C, and D, E, F. What you can do is you can kind of line them up so that way you know which points go with them. So we're going to say that A goes with D, so that means that we're going to have, this is going to be D right here. B goes with E, so that's going to be up here. And F is going to be that third point down here. So that means, again, that length is going to be 5 on the edge here. And so when it says similar, what does that mean? Well, anytime it says similar, that just means it's going to be proportional. Proportional. That means if we multiply it by a certain scale factor, we should be able to get our new triangle. So what we're trying to figure out is how we went from 10 to 5. And so if we say this, if we say the scale factor, so let me say the scale factor is 1/2, since 1/2 times 10 is equal to 5. So then we say we take 1/2 times each of the original values to get new corresponding sides. And what it means to have corresponding, that means they go with one another. So like I was saying, that side, this side AC is going to go with that side DF. And then this side EF is going to go with that side BC. So make sure that they are matching up like we have. So that means if we take 8 times 1/2, it's going to be equal to 4. So that's going to be 4 centimeters. And if we have, the other one is 6, so we have 6 times 1/2 is going to be equal to 3. So this other side, DE, is going to be 3 centimeters. Try writing that again, 3 centimeters. All right. Moving on to the last one. It says Elena and Jada are distributing flyers for different advertising companies. Elena gets paid 65 cents for every 10 flyers she distributes, and Jada gets paid 75 cents for every 12 flyers she distributes. Draw the graphs on the coordinate plane represent the total amount of each of them earned, Y, after distributing X flyers. Use the graph to decide who gets paid more after distributing 14 flyers. So what we're going to say is this. So what we can first say is that both graphs are proportional since they go through that point. So we can say both graphs are proportional since they go through 0, 0. So that's going to be that origin down here. So on our x-axis, we have flyers. On our y-axis, we have the cents, so how much they're getting paid. So let's plot these 2 points. So I'm going to say, let's do blue for Elena. So I'm going to plot Elena's point as 10, so let's say Elena's point is 10, 65. So let me plot that down. So go over to 10, go up to 65, plot that point. And for Jada's, however, in red, Jada's point is going to be 12, 75. So I'm going to go over 12, go up to 75. Let me label those two as Elena and Jada. So those are the 2 points. Make sure you can graph your 2 lines. So I'm going to go from the point 0, 0 the whole way to Elena's line. And then I can graph from 0, 0 to Jada's line of 12, 75. And so if you look at these two, we can notice one thing. We're trying to figure out how much they'll get paid. Well, if you look at this, I can compare those slopes. So what I'm going to do is I'm going to say this. I'm going to say Elena is paid more since her graph is steeper than Jada's. So since she has a steeper slope, she'll actually get paid more per flyer. So then lastly, for the X ticket, it says this. It says to rewrite 10 to the 32 power times 10 to the 6 power using a single exponent. You gotta make sure you can add those exponents together. Then it says, for number 2, it says each year roughly 10 to the 6 computer programmers each make about 10 to the 5th power dollars. How much money is that altogether? Express your answer both as a power of 10 and as a dollar amount. So that means you have to expand it out. So just make sure that you're asking questions as they come up. And as always, super slam that subscribe button.